Friends, in this video we are going to discuss a Leetcode problem of the day, balance a binary search tree. So the problem is similar to the yesterday's problem. Okay, basically what the problem statement says that, let's read the question. Okay, given the root of a binary search tree, return the balanced binary search tree with the same node values. Okay, if there are more than one answer, return any of them. A binary search tree is balanced if the depth of the two subtree of every node never differs by more than one. Okay, so basically in this we have been given a binary search tree. Okay, basically a simple binary search tree is what? Let's see. This is 1, 2, 3 and 4. This is the root of the binary search tree we have been given, and we have to balance it. Balancing a binary search tree means what? In balancing, we have to arrange the nodes of the subtree, means the left child and the right child, in such a way that the left child is always smaller than the right child. Okay, so in this way we have to arrange. So we have been given this 2, for example. We have been given this 2, so our left child is smaller than the right child. This right child, this is 3 is the right child, and our left child is what? 1. This is left and this is right, as you can see. Now 3 has another right child, 4. Okay, so its left child is what? None. It's null. Okay, its left child is null. So in this way we have to solve the problem, means the left is always smaller than the right. Okay, the left child is always smaller than the right child, and the difference, okay, and they differs more than one. The difference must not be more than one. Okay, means as you can see here, yes, this difference, it's 1. The difference of 3 minus 2 is 1, also 2 minus 1 is 1. So their difference, 2 minus 3 is what? 1. Also 1 minus 2 is what? 1. So their difference is what? 1 minus 1 equals to 0. So it's less than 1. It must be less than 1. Okay, so this is basically the problem statement. There is another example also. Let's discuss a bigger example. Okay, like sometimes 3, 9, 20, sorry, 15, 20, uh, let's have another one, 17 and 20. Okay, now it's pretty good. Okay, so this root of a node we have been given here. Wait a minute. Okay, so this root of the node we have been given here in this. So as you can see that every element is greater than the previous element. Okay, so how can we form the binary search tree here? Okay, so how come we can form? We can form by this also, by 9, its left element must be smaller. Okay, now its right element must be greater. It is what basically, let's suppose it's 17. Okay, it's 17, so its left element must be 15 and right element must be 20. So these kinds of binary search tree we can form, and as you can see in the question itself, you can return any of the answer. Okay, any of the answer you can return. So basically it has more than one answer. So I have found the most basic approach to solve this problem. Most basic approach to solve these problems, we will start from the middle element. Okay, we will start from the middle element. As you can see, the length of the binary search tree is what, 5. The length is what, 5. Okay, as you can see, we have 5 elements here, 1 2 3 4 5. So we will find the middle one. We will just find the middle of the element. Okay, so it can be basically what, it can be our new balance subtree will be, can be 3 elements smaller, 9, 20, then 15, wait a minute, it's not more precise one. We can start from like just 15 also, because it's the middle of the element. Okay, we can start from 15 also. It can be 15, then a more smaller element can be what, basically 9. It can be 9, and then a bigger element, a more bigger element is what, basically 20. Okay, now a smaller element than 9 is what, 3. So it's, there comes a 3. Okay, now the smaller element than 15 is 17. Okay, so basically what we can see, that this is the balanced binary search tree we have found, by finding the middle of the element. Okay, so how come we can solve the problem by just finding the middle of the element? Okay, first of all, we will do the in order traversal. We will just do the in order traversal. Okay, then we will do the left subtree traversal and append the values, and then right subtree traversal, and then backtracking. Okay, let's see how we can solve the problem. So basically here, as you can see, for example, let's suppose you have been given a binary search tree as 1 2 3 4 5 6 7. Okay, let's suppose you have been given 1 2 3 4 5 6 7. Okay, so how come we can find the means balance of tree? The middle of the element is what, 4 here. Our middle of the element is 4. It's the mid. Okay, so the topest element will be 4 here. Okay, then we have the two sub elements left here, as you can see. So here Here the middle one is what? 2. So we will have 2 here, and also here the middle one is what? 6. So we will have 6 here. Okay, we got 6. Then we have 1 3 left with us. We have 1 3 and 5 6 left, 5 7 left with us. So we will add the smaller element in the left side 1 and the bigger element in the right side. Okay, here same, smaller element 5 and bigger element 7. So this is our binary, means balanced binary search tree. Okay, so in this way, by finding the middle of the elements, we can solve the problem. Okay, let's try to understand with it with the help of the code. It will be more precise for you to understand. Yes, first of all we are creating a array called nodes, array, or we can say a list. Okay, we will perform in order traversal to collect the nodes. Perform in order traversal to collect the nodes, to collect the nodes. Okay, now we will create a function called def in order, and we will create a root in it. Okay, the in order of root traverse the tree and append each node to the nodes list. Okay, where we will just go on traversing and appending here. So if not root, if our root is null. Okay, if our root is null, we will just return. We will just return. Okay, now in order root dot left means we are traversing the left root. Okay, then nodes dot append, will append the value of root. Okay, now we will traverse the right root, means the smaller element. Okay, now we will create a balance and binary search tree from the sorted nodes. Create a balanced binary search tree from sorted nodes. Binary search tree. Okay, we are creating a balanced binary search tree. Okay, def bst. Okay, we will use the middle of the element as the root to ensure balanced structure. Okay, the left and right subtrees are constructed recursively from the left and right halves of the current segment of the list. Okay, so in this way we will solve the problem. We will take left and right recursively, then we will check if our left is greater than right. If our left is greater than right, we will return what? We will return none. Okay, why? Because in this you can see in this figure, every element in the left side is smaller than the node. Okay, every element in the left side is smaller than the right side also, so that's why you have to use this statement. Okay, now let's move forward. Hmm. Now we are taking the middle of the element. Okay, we are taking now the middle of the element as L plus R by 2. Okay, now we are initializing the root to nodes. Okay, root equals to nodes of M means middle element to the sorted array. Okay, now we will initialize the root dot left equals to dst of left to mid minus 1. Okay, now and the right root to from mid plus 1 to right. Yes, mid plus 1 to right. Okay, now we will return the root. Okay, now initialize the in order root. Okay, and return the bst from 0 to length of the array. Now let's try to run it. It's giving some unknown error. Let's try to debug it. I think there is a problem in returning the values. Here there is a problem in the indentation. Here indentation error is there. It must be there. Okay, now let's try to run it. List index out of range. Okay. Yeah, it's giving now the correct output. Let's try to submit it. Yeah, it's being accepted here. Basically, what's the approach behind the left to mid plus 1 and mid plus 1 to right? Okay, left to mid plus 1 and mid plus 1 to right. Sorry, mid minus 1 and mid plus 1 to right. Okay, here our middle element was 4. Okay, as you can see, our middle element was 4 here. So our this area this area is what? Left to mid minus 1. Okay, and this area is mid plus 1 to right. Okay, so we are means solving the problem from the left side of the mid and the right side of the mid. Okay, this basically is the left side, and this is basically the right side. Okay, as you can see, this is the left side and this is the right side. Okay, so in this way we have to solve the problem. I am uploading the code in the Google Drive, right? So you can see it. So thank you guys. If you have any of the doubt, you can ask me in the comment section.